Hi guys, welcome back to the channel. Today we are going to be using and understanding textual processing in Bash. Text processing refers to reading, analyzing, modifying and transforming text data using command line tools. In Linux and Unix based systems, text is a primary form of data representation. Therefore, your skills in manipulating this particular set of data as a system administrator or a data analyst is highly useful when it comes to a job environment. Most of the text data that you would be encountering would be log files, configuration files, CSV or TSV files, source code files, or plain textual reports. Usually, some of these built-in commands such as grep, sed, and awk are inbuilt tools which allow you to search, extract, replace, and format the structure of this textual data in an efficient manner without the help of fully fledged programming languages like Python or Java. Therefore, using command line text processing, unlike the help of GUI based text editors, you can efficiently automate some workflows, minimize the amount of resource. Therefore, you are able to execute lightweight terminal commands, implement pipeline processing, and use regular expressions. Some of these core tools for Bash text processing are as follows. As you can see, Grep stands for Global Regular Expression Print. This particular core tool in Bash text processing can be used for searching and filtering text-based patterns from specific files. These files, as I have previously mentioned, can be log files, text files, or any other form of a file. Sed is a short form for stream editor, which can be used for modifying and transforming your text in a file or in a stream. You can basically replace IP addresses from config files and more, while awk basically stands for Ahom, Wernberger, and Kernighan. These are the names of the creators of the specific tools, and it is commonly used for pattern matching and processing and extracting structured textual data. Now that we have a strong foundation of why textual processing is important and some of these tools that we will be using, we will be moving on to our first command, which is grep. Now let's start with our first tool, grep. If you have ever searched for a keyword within a file using the command line, there's a good chance you would have used grep. This command is an abbreviation for Global Regular Expression Print and is one of the most commonly used tools for the process of searching Unix or Linux text or any other particular text data. So what is grep? At the core of it, it basically allows you to search for specific patterns within a file or standard input, return the matching lines, and is commonly used for log analysis, filtering structured text, and debugging. The particular structure of grep would look like something like this. Here we would like to write some specific options followed by our pattern followed by the name of the file. So trying to break down the components. Grep is the command itself. The options are the various flags and tags which can modify the behavior. The pattern is the text or the regular expression which we are trying to search for, and the name of the file itself or the file which we are trying to work with. For this first example, we will search for specific simple words from a server log file with the following content. So let's just see. I have a bunch of files in my working directory. In this case, we will be using server.log for some of these basic works. So as you can see, this is the content. So as to see, you can see that there is a bunch of info, warning, errors, a bunch of messages regards to servers, some messages regards to memory, trying to connect to database, IP information, and so a lot of information here. So we can try to filter out some of this information with the help of the grep command. For example, let's say we are trying to look up all the lines which contain the word error. So we will write grep error followed by the name of the text file or the log file, and once you hit enter you would see an output which looks something like this. So what did we do here? We basically asked Grep to read the file called server.log line by line. Here it would compare each of the lines with the pattern where this specific pattern or the error basically matches. So it is very key to understand that the text that you are searching for has to match up exactly. So here the case sensitivity is of prime importance. Here the lines would be compared one by one, and once the pattern has been found, it would basically print it out as a standard output. So yeah, so there are other specific tags which basically modifies the behavior of this command. We can try to use some of those here. So let's just clear our workspace. Let's say I want to perform a case insensitive search for the very same error pattern that we were looking for in this specific log file. So let's say we write grep, same command as before, however here we would mention -i. So this option or tag or flag or whatever you want to call it is an option which is available to us to specify to the grep command that we would like to right now perform a case insensitive search within server.log, and once I hit enter you can see that I'm getting the pattern found. But here let's just modify this and let's just put it as small letters in lowercase, and once I hit enter you can see that I get the same output just like before. So it pretty much works. This is useful whenever you want to deal with case variations in the text. Sometimes the logs might have the error inconsistently or the pattern inconsistently set, so and you would like to make sure that all the variations are found. Sometimes other factors also come into play, but this pretty much helps you get uniform results. Another example would be looking up inverted matches. So what are inverted matches? Well, this was a flag called -v which allows us to exclude lines which contain a specific pattern and display everything else. So for example, if I write grep -v followed by the pattern that I would like to exclude and hit enter, you can see that I have basically, okay, let me just change. So as I have previously mentioned, the case is of prime importance, else it will not work. So as you can see here, we are now getting a far better result. Here all the lines which contain the pattern error have been excluded, and we are only getting the lines which do not have this specific pattern. So here we have performed an inverted search. That's how we use -v. Now let's say we want to show the line numbers against our specific output. So for that we will basically use another flag called -n. So the -n flag adds the line numbers at the beginning of each of the matched lines, and this is useful for quickly locating errors in the large file. For example, if we write grep, same command as before, here instead of -v we will write -n, and here we would output the same result as before, but the only difference is that here we are able to also see the specific line number where this specific pattern has been found. We can also perform important results with regards to counting how many times this specific pattern would appear within the particular file instead of just printing the number of lines. So for that there is another option or flag available which is called -c. So we will write grep -c, the same pattern as before, and the name of our particular log file, and hit enter. As you can see, our outputs always were 2, and here we have gotten hold of the particular number which is 2. So this is useful whenever you would like to look up the number of occurrences rather than the full output itself. Another flag which is available in context of grep to modify its behavior is -o. Let's say you would like to extract specific parts of the text. uh, Here we would use -o, which would only print the matching portion of each line instead of the whole line. So let's say we have an IP address, so which looks somewhat like this, and we would like to basically extract all of the IP addresses ending with numbers from 0 to 9. So this particular number or value uh, can range from 0 to 9. So for that you would use a regular expression. So we will clear out the workspace, we will write grep -o, mention the pattern, which is the IP address, something like 168.1. Here we would specify our exact regular expression spanning from 0 to 9 and the star symbol. So here we have mentioned that we would basically get hold of any of the values of the IP address where this particular value can range from 0 to 9. Here we will later on specify the specific log file and hit enter, and now you can see that we have returned the exact match. The grep command can also be combined with other commands with the help of the pipe command. So the pipe symbol, if you are not aware of, is just a vertical line. Here we are basically taking the output of one command and passing it on to the other command. So the output of one command gets processed by another command. So this is pretty much the syntax. So let's say if you have a process and you would like, so this command would basically give you the list of all the running processes in your Ubuntu system. Let's clear this, and we would like to get hold of all the processes where you have Apache. So you would write grep, and let's write Apache and hit enter. So yeah, this is a form of filtration. So you have basically performed a chaining of commands, and this is pretty much powerful whenever you would like to filter out specific processes. And then there are other real world applications of grep. Let's say you would like to look up specific errors within log files. You would perform the command just like before. Let's say field SSH logins, you can do that also in context of authorization logs. Let's say you would like to look up specific information associated with users, filtering out IPs just as we did right now. Then there are also other variations. This was just a simple example. Performing audits, looking for brute force attempts and unauthorized access. So there are several things that can be done, and yeah, let's just look up all the commands that we just did for the purposes of recap. So you can see here the options for all the grep commands have been given. -I is used for case insensitive search. Let's say you would like to look up an error message in a server log. You basically use grep -I followed by the specific pattern you are looking for, followed by the specific file. -V can perform inverted matches. Let's say you are looking up for all the lines where this specific pattern doesn't occur. You use -V. Let's say you would like to look up all the numbers or line numbers where this specific pattern occurs, just like before. You would use grep -n followed by the pattern and then the name of the log file. Let's say you would like to look up the number of occurrences. You would use the -c. Just like before, this is the specific pattern that you could follow. And in order to extract specific matches, you would use grep -o, the particular pattern and the name of the particular specific text file that you have in mind. So yeah, this pretty much covers all of grep. We will like to move to the next segment where we can talk about sed. So yeah, now we will talk about stream editing in bash. Stream editor or sed is one of the primary non-interactive text editors which are commonly used for modifying and transforming text in files or streams. Unlike the traditional text editors, sed basically operates on input streams and applies these changes on the fly, making it ideal for scripting and automation. So yeah, why use sed? It is efficient to process large files. We can automate replacement of text. Let's say you would like to insert, delete or reformat, that can be done. You would like to filter specific parts of the text dynamically, that is also possible. In the previous case we talked about grep. The syntactical nature of sed is somewhat similar to grep, where you would specify sed followed by the options, followed by the script that you would like to perform, and the name of the file. To break it down, sed is the command itself. The options are the flags or tags that basically modify this behavior. Script is the transformation operation that you would like to perform or apply, and the name of the file is basically this file that you would like to process. So yeah, I'm gonna perform these tasks on a file called employee.txt. Let's see the contents of employee.txt. As you can see, it's a list of employees and their roles. Let's say you would like to replace the term engineer with senior engineer in the column 2 or field 2, and let's just clear the workspace for that. So yeah, let's perform the process of replacing engineer with senior engineer. We will write sed. Okay, I have already written something here, so you can just use this. In this case we would like to replace engineer with senior engineer, so we will write senior engineer and close this. Always remember, it is essential that you would open and close your patterns with the forward slashes, and we would hit enter. As you can see, the output, you can compare it with the previous output. The engineer terminology has been replaced with our specific pattern, which is senior engineer. Here the substitution command or S replaces the first occurrence of engineer per line, and only the first matches per line will get replaced. So as you can see, all the patterns have been replaced. And let's say in this particular scenario we have multiple instances of engineer within the single line, and for that let's just create a new text file. So let me just create nano sample.txt, hit enter, go into so let's just write some name. Let's say something similar to this. Let's write our terms. And yeah, let's just write something like this. So in order to make this clear, I would like to just perform this operation. Here, let's just go to sample.txt. Here the term engineer occurs multiple times on the same line. However, on this case, if you perform the same command as before on the samples.txt, sample.txt, and hit enter, you would see that only the first occurrence of this specific pattern that we would like to replace is getting modified. So this is not good, so we would like to change this back, and we will write sample.txt. So yeah, in order to replace all these occurrences for each of these lines, you would specify a global flag or -g. So let's just set up our pattern as before. In this case, I would like to replace engineer with senior engineer for all the occurrences of this term engineer, and I will specify the correct text file and hit enter. And here you can see that the term engineer has been replaced with senior engineer for all the patterns that we have intended for it to be replaced, and that is only possible because we specified that we would like to replace or substitute this term globally for all the terms that are occurring, and therefore we have done so by adding G or global, which ensures all the occurrences in each line getting replaced. So yeah, let's say let's just clear out our workspace. Let's say we would like to perform a case insensitive replacement. For that, it is also possible by mentioning the I flag in our substitution pattern. So here we have let's just see what are the files that we have. We have employee.txt. In order to make it a little bit more workable for our next example, I would like to modify this text file, and let's add let's say something like some name like this, and we will write, let's say, manager. In small case, let's write something like this for this particular pattern. Let's just say I'm just entering random terms which I can just show for the next example. So yeah, here we have entered a bunch of case insensitive patterns. We will clear out the workspace, and let's say I would like to replace the term engineer. As you can see, there are multiple variants of cases for the particular term engineer, and I would like to replace it with senior engineer. And since we have now entered a new conundrum where this case is different, I would like to find a solution. So for that, you would write the same pattern as before with correct text file, and here instead of G I would mention capital I. So we have basically asked SED to search for case sensitive pattern for the term engineer and replace it with senior engineer. Once I hit enter, you can see that all the terms where the particular term engineer used to exist has been replaced with our secondary replacement. So you can see that it has been replaced at 3 places. So yeah, SED also allows us to specifically delete lines from your specific text files. Let's say here I have employees.txt, and you would like to delete line number 2 from this specific text file. For that, you would write SED to D followed by the specific text file and hit enter. As you can see, we just removed a line, specifically line number 2 from this employees.txt. The option 2D basically deletes that specific line. Here you can also mention 3D, 4D, or whatever number depending on that specific line that you would like to get rid of. Also, let's say you'd like to delete a specific line where a pattern has been found in employees.txt. Let's say we want to get rid of all the lines where this term called intern is present. So let's go ahead and write sed intern d and employees.txt. Here you would see something strange. Since the term intern occurs in various cases, sed is not able to differentiate and therefore it doesn't delete that specific line. So for that you have to add a specific case insensitive flag in order to get rid of these lines where this variation is occurring. So you would write the same pattern as before, but here you would mention I followed by D and then the name of the text file and hit enter. Now you would see that all the occurrences of the pattern intern have been deleted. This is a kind of a kink in sed. So yeah, just as a heads up, this can happen. Yeah, moving on, sed or stream editor can also allow us to insert, append text data into specific lines. Let's say we would like to insert HR department before the pattern manager or any of the lines where this specific term manager occurs. So for that, here since we have let's say cat employees.txt, yeah, in the first line itself we have the pattern manager and we would like to insert, let's say, HR department or something like that. So we can clear the workspace. We will write sed, let's say manager, okay, / I and then the specific text that you would like to insert and then the specific text file at hand. So you would write something like this and hit enter. So you can see that let's break down the components. We have specified a pattern which is manager. This would find the lines where this specific pattern exists. HR department would insert this term HR department before any of these patterns. So yeah, that's one way of doing this. Let's say we would like to add a line after a particular match. Let's say we would like to append promoted after every engineer. So for that we would use the option A. So let's use sed and write / engineer and we would append the term promoted and then the text file, and you can see that here we have just inserted the term promoted after each match of the pattern engineer. So yeah, that's one way of doing this. Let's say we would like to change or save the changes to a particular file. By default here you would like to be let's say this is safe in a way that these changes that we have made have not been saved. So this is only printing out the changes without modifying the original file. So in order to permanently modify a file, let's say we would like to get replace, let's say here since we have intern and we would like to replace interns as junior employee, let's just write sed -I and let's write s. We are substituting the term intern for junior employee and then the text file. Let's see the change. you can see that here, since we only mentioned a small case, only okay okay now let me just replace the spelling error here. We would like to replace this erroneous entry into the correct term. Hit enter. Yeah, always remember to close out your patterns with the closing forward slash in order to make sure your changes are reflected. Let's just see the particular text file. Yeah, as you can see, the correction has been made. As I was mentioning, since the case that we had previously mentioned was in a small case, only that particular match was found and was replaced, and these changes are permanent. And let's just make the change possible for the small irrespective of the case. And let's just modify our yeah our text and hit enter. Let me just clear the workspace and let's see how our replacement has worked out. And here you can see that the secondary replacement, where the case was having a small variation, has also been replaced because we used capital I, which specifies case insensitive replacement. So yeah, there are several real world applications for SED. Let's say you would like to get rid of unwanted log messages like debug. You can do that. Let's say you would like to get rid of some default port values from a config file, or perform some replacement within scripts. That's also possible. So in order to summarize all of these changes that we just demonstrated, I have a table. Let's just look at that table for a moment. Yeah, so you can see SED basically has several options. Let's say in order to replace one of the old matches, let's say an old pattern, it will replace that first occurrence once per line. But in order to replace all the occurrences, you would like to specify, oh, I'm sorry, it's a bit small, but I hope it's visible. So here we are replacing the term old with new globally, and therefore that would replace all the matches. In order to perform case insensitive replacement, you would specify the capital I at the end of the substitution SED command that we just give out. This would replace all the text irrespective of the case. In order to delete a specific line, let's say getting rid of line number 2, you would write 2D. Let's say if you want to get rid of 7th line, you will write 7D, and so on. In order to get rid of specific pattern, you would write SED pattern followed by D, so it will remove the line where the specific match has been found. Let's say you would like to insert some matches. Insert before certain matches, you will write SED /pattern/I, then the specific term that you would like to insert followed by the specific text file, and yeah, that would add that line before that particular match. In order to append after that particular match, you would write A, the same as before, but instead of I you would write A. And yeah, in order to edit the file in place, permanent changes, if you want to make sure you would like to change that, you would write -I before that particular replacement that you're performing. So yeah, I hope you understood what we did with SED, and we will now move with awk. So yeah, the next segment that we will be talking into is gonna be awk. Awk, as you have previously seen, is just like Grep and said. Awk, however, is more powerful of a tool for processing your patterns and your data and you can perform various other aspects like textual transformation. Unlike SED or stream editor before, which is used for tasks such as substitution, awk looks more like a programming environment when it comes to working with variables, loops and conditional, as well as some mathematical operations. So awk can allow you to do column based textual processing, especially on CSVs. You can work with inbuilt variables and functions. You can perform pattern matching and even mathematical and string operations in context of complex data analysis. Just like before, the awk syntactical structure looks somewhat like this, where we specify the pattern followed by the action that we would like to perform within the same single quotes and the name of the file. So in order to break it down to you, awk is the command itself. The pattern here is the condition that determines whether that particular action that we are mentioning, which is suffixed to this particular term, whether that particular action needs to get executed. The action here is a set of commands that will execute when the pattern is matched and the file onto which we would like to perform this process. For the purposes of this demonstration for awk, I have a bunch of files. Let's see, employees.csv. So here I have employees.csv. You can see there are 4 columns. First column is the ID, second column is the name, third column is the department, and the fourth column is the salary. So you can see that there is engineering, HR and finance, and there are some simple names and some salary values. So yeah, let's go ahead and start working with awk. Let's say you would like to extract a specific column. Let's say we would like to print only the names of the employees. For that you would use a tag called -f followed by the separator. So here we would write the command somewhat like awk -f followed by the separator, and here we would like to mention what action we would like to perform, which is to print the second column followed by our employees.csv file. So let's break this down. Here we have mentioned a option called -f. This is a field separator which we have to specify. In this case we are looking up specific field separator like a comma within this CSV file. The second part of this command is the action, which would print out that specific second column which corresponds with the name, and here the $1, 2 or 3, this basically represents the field or the column on each line. So if you would like to print the first column, it would be $1, third column it would be $3, fourth column it would be $4, and so on. So in this case we are only interested in getting hold of the names, and once I hit enter, you can see that we have gotten hold of the name column. So yeah, similarly we can also extract multiple columns. Let's say we would like to get hold of the name and the salary. If my memory is correct, the salary column was the fourth column. You would write $4. We are clubbing these two together, and once I hit enter, you would see that we have successfully extracted the name column and the salary column as well. So in order to break it down, $2 refers to the extraction of the name column, while the $4 refers to the salary column. And since we have mentioned the action print, we would print both the columns separated by a space. So you can see that there is a space value separating these two columns or fields. So that's pretty much how the process of extraction of printing specific columns works out. but let's say we would like to perform the operation of filtering data in context of certain conditions. So let's see what our structure looks like. So here you can see that we have a column called department, and there is engineering occurring twice. Let's say we would like to get hold of the name and let's say the salary for all the employees from this particular CSV file where the department is engineering. So it's a pretty much like a proto SQL command structure which we are performing with awk. So we would write awk -f. The field separator is the comma, and let's say instead of just performing the action of printing, we would like to also specify the condition. So here we would like to match the third column, which is the department, with engineering. Here always remember you have to specify double equals because we are trying to match the specific department, so which is engineering. We'll specify the space to put the action as a separate part. And yeah, so what have we done here? So here $3 double equals engineering is a condition which only would process the lines where the third column is, or the department is engineering. The action here which we have mentioned is the print statement, which will print out the name and the salary. And once I hit enter, you would see that John Doe and Alice Johnson from this specific CSV file are part of the engineering department, and we have basically printed it out. Let's just see if this is accurate. So you can see that John Doe from engineering earns somewhat 60,000, and Alice Jones from engineering is earning 70,000. So yeah, this is actually correct. Now let's say I would like to get hold of let's say finance department. I can basically go ahead and modify the same command structure and write finance and hit enter. You can see that we have gotten hold of that specific entry. So this is pretty interesting. Now let's see, we can do a little bit more interesting things. Let's say we want to get hold of all the employees whose salary is above 60,000. So you would write awk -f. The field separator is comma, and here we would like to match all the columns where the salary, which is the fourth column, greater than 60,000. So we will write 60,000, and the action which is to print the name and the salary. Okay, so for the sake of our output, let's also print out the department as well. And when I hit enter, you will see that I have printed out the name, the department, and the salary. So we only have one individual who's earning more than 60,000. So breaking down the command, we basically specify $4, which is the salary column with the condition greater than 60,000. So whenever we get this particular match, we would perform the action of printing out all the column values spanning from 2 to 4. So here it is $2, 3, and 4 from employees.csv. So yeah, this is one of the ways to work with filtering. Let's say now we would like to add a header to our output. So yeah, for this there is a new thing that we would like to mention, which is NR. So NR is a condition that we specify to print the first row or the header values. So here if we would like to print out all the values where the employee salary is about 60,000 along with the headers, we will write awk -f. We have to specify the field separator, and here we would write NR matching 1, and we basically specify the separator, which is double vertical bars, and the same condition as before. and the command structure remains the same. And once I hit enter, you can see that I have printed out the header values as well. But it depends on the kind of Ubuntu or Linux distro you are using. As you would notice, in the previous cases I was pretty much getting the header values as well. In some cases you would not see this header value from the CSV, so in that case you would specify nr equals to the first row, which would be the header values which we are printing out. So I hope that is pretty much clear. So yeah, we can also go ahead and perform interesting calculations on this. Let's say we would like to calculate the average salary. So for that, we would now start entering a territory where the awk command starts to look a little bit more complex. So you would write awk hyphen the field separator, and here you would like to specify, okay, let me just clear out the entire command. Here you will write the row values greater than 1. Here we would perform sum. This is a variable which we are basically calculating. Here we are basically adding up all the salary values in the particular variable called sum. So here we would write $4, which is the salary column, and we have to also increment the counter, and in the end you would like to print out this particular output. So you write print, you can write your message as average salary, and you would like to perform the operation of averages. So since we already summed up all the values in the sum variable and have counted all the number of occurrences in the count value variable value, so you will write sum divided by count, and you would like to perform this task. Let's close out the entire action command part of this, and then we will specify the employees.csv and hit enter, and you can see that the average salary is 47,000. 47,000. So yeah, here we basically have mentioned the header row, followed by the sum values, which would add up all the salary, and we also have another variable called count, which would increment based on the number of rows, and the end statement, which basically will print out the average salary after processing all of this. So yeah, that brings us to the end of awk. There are some other advanced features as well in awk, which we will dive into in the next segment, where we will try to implement some really hardcore script running as well as formatted outputs, which we did not cover in this segment, but I will keep it for the next one because these are some advanced concepts. So yeah, let's just try to recap what we did as of today. You would see that we have performed extraction of singular columns with the help of awk, where we basically followed a structure similar to this. In this case, it will return the second column from file.csv, and here we have utilized the field separator as comma. Multiple columns can also be returned in a similar fashion by specifying the specific column number or field number here, which could be $2 and 4 in order to print out those specific selected columns. You can also filter out rows based on specific condition here, as we have done previously in one of the samples. In this case, we are only filtering out the second column where the condition for the column 4 is greater than 60,000 from file.csv. Um, the nr command, the nr specifies a specific row that you would like to skip. Usually this is clubbed together in order to make sure that your calculations which you are performing with awk are not um, gonna get erroneously outputted, because sometimes the data types are different. The header here, which is the first row, usually is refers to the column names, which is name, salary, and so on. These are the string values, and if you perform like some operation like this, you might get some error because the data types are different. So usually in this case you write nr greater than 1. So if that was not clear before, I hope it is clear now. We will try to cover the formatted output and script running in the next segment, so you can ignore these two for the time being. So yeah, these two we will just cover up in the next segment. So similar to this, you can also see we just calculated summation of specific columns by adding the column values. In this scenario, we are just summing up all the values on column number 4 and printing out with an end statement, where we just print out the variable which contains all the summed up values from file.csv. So I hope you understood a lot with regards to string editing, stream editing, and working with different forms of text in Linux. And I will try to cover the formatted and unformatted forms of working with all of these together in a final example in the next segment. So I will see you in the next one. Bye.